do that now. Okay, so yeah, I'm just going to reiterate what I was saying, just for those of you who are on the recording and watching. If you go under files, you're looking for extra practice, go under extra lecture notes. I'm posting these each lecture that we have. Basically, like for example, for lecture 3, we've got, I talked about constant functions, linear functions, and so on and so forth. You can see just my personal kind of notes that I was taking, like in preparation for the course. You can kind of, it's pretty detailed. I talk about exactly what to look for. Even if you're prepping for a course, a class, like if you're doing lecture prep, you want to come back here and take a look at extra lecture notes. That might be good too. But what's important for test 1 is the fact that there is a study guide, and the study guide has a bunch of terms here, a ton of different terms, different kind of things you should know, like key concepts and so on and so forth, midpoint, for example, defining the distance. And I created all this stuff just for you guys, so you can like kind of have a comprehensive place for all this. And then if you want even more practice, take a look at the actual practice exam. This is not how the exam is going to be, because the exam is actually, or I keep saying exam, but your test 1 is actually going to be a lot like the actual practice test through MyLab. It's going to be a MyLab test, okay? This is just for practice, so don't get caught up in terms of format. This is just the types of problems you might see. And the last 2 types of problems you won't see, you won't see any piecewise functions. And then as far as translating, you probably won't see any of those for real, or you might, but not much. So anyway, I guess the last problem, cut that, but the answers are at the end. But if you want more practice, you definitely can use this. But yeah, I know we had somebody just join, and I'm just taking questions, any specific ones. I can pull up the test here and try to get those answered. So do you have a specific question? Any question in general on maybe the
Yes,
test?
sir, I have a question.
Okay, great.
I have a question regarding to question number 9.
Okay. Let me see here. Question number 9. Let's take a look. Oh, no.
That's fine though.
Yeah, no, we're not gonna do that.
I'll be grateful.
All right. So yeah, all right. So we've got question 9. Okay, so just kind of how to do it. You want me to go through like the whole thing? Okay,
actually, my issue is with finding the intercepts.
Okay, all right. So let's see. So for the question, blah, 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 do the following. First, find the center HK and radius of the circle. So I tell you what, why don't I just go through the whole problem, especially since I'm recording this and somebody might need me to go through the whole thing. So I kind of walk through it, and it actually might be helpful. Yeah, thank you. All right, so first thing I'm going to do is I'm going to say, okay, let me rewrite the equation. We got x squared, there must be a delay here, plus y squared minus 4x minus 2y minus 11 is equal to 0. Okay, so basically what I want to do at this point, you want to put your x's together and your y's together. X squared minus 4x plus y squared minus 2y is equal to 11. So putting the x's together, the y's together, and the numbers on the other side. We then we're going to use that completing the square method. So basically what you're going to do is you're going to look at that b term, which is your second term, your linear term, this term right here. And we're going to say, okay, I'm going to do negative 4 divided by 2, which is negative 2, right?
Mm-hmm.
And then square it, which is
4.
Or 4, right? So, oops. So we're negative b over 2 squared. So basically what you'll end up with is x squared minus 4x plus 4, and then plus, and then do the same thing over here. Get negative 2 over 2 squared, which is 1 squared, which is 1. So you know with plus y squared 2y plus 1 equals 11. But remember we added 4 and 1, so we do plus.
Then we
4.
count them together, and here we get the radius.
Exactly. So you end up with x minus 2 squared. And the reason why I know that those 3 terms will be x minus 2 squared, so these 3 terms, the ones I'm looking at, are because this middle number was negative 2, and then plus y minus 1 squared, same thing. This was negative 1, and then it's equal to, and we add these 3 together, get over 16. So the key is we're saying that the center, so your HK value, your center is going to be 2, 1.
And the radius is going to be 4.
Exactly. You're absolutely right. Radius is 4. Now, your question was on intercepts specifically.
Yes.
Now, the key to finding the intercepts is
through this equation.
Exactly.
Yeah.
So basically, if we want to find the y, intercept, then we set x equal to 0. So what we can do is you can do 0 minus 2 squared plus y minus 1 squared is equal to 16. So 0 minus 2 squared, that's going to be negative 2 squared, which is 4. Plus, and then I'm just going to keep this like this. Y minus 1 squared equals 16. I'll show you in a minute why. I can subtract 4 on both sides, which gives me y minus 1 squared is equal to 12. And then I'm going to take the square root of both sides, which gives me y minus 1 equals the square root of 12. And technically, it should be plus or minus the square root of 12.
I missed how did you find the 12?
Yeah, that's a good question. So basically what I did was I subtract 4 on both sides.
Oh, okay, got
it. Yeah. Great question. And then, with y is equal to positive 1 plus or minus square root of 12. But the square root of 12, we can break this down into like 4 times 3.
Yes, sir.
So
then we write as 2 and 3 inside the root.
Yeah, you're absolutely correct. So these are our 2 spots. Basically, you're going to have 0, 1 plus 2 root 3 and 0, 1 minus 2 root 3. Those are your two y-intercepts. Now, for the x-intercepts, we're going to
replace the y with 0.
Exactly. So you're going to have...
You got to know this about me. I'm the dumbest person in math.
No. You're fine. You're doing really well, actually.
So please be patient with me.
No. I'm here. No, you're doing very well. So you got 0 minus 1 squared. You're absolutely right. Is equal to 16. Then we got x minus 2 squared is plus 1 equals 16. And I'm getting plus 1 because we have 0 minus 1, which is negative 1 squared. So negative 1 squared, negative 1 times negative 1, that's 1. So yeah. And we're going to subtract 1 from both sides. We end up with x minus 2 squared is equal to 15. And therefore, you end up with x minus 2 equals plus or minus root 15. Now, there's not really anything to do with this root 15, because if we look at 15 itself, it breaks down to 3 and 5, and both are odd. So you can't break it down further.
So we write it as is.
Right, exactly. So basically, when we add 2 to both sides here, we'll end up with x equals 2 plus or minus root 15. And so if we put it all together, we end up with 2 plus root 15, and then comma 0, and 2 minus root 15, comma 0, because our y value is 0. And these 4 are your intercepts. Yeah. So what we would do is, okay, we got our center was at 2, 5, I believe.
It was minus 2 and minus 1.
Was it minus 2 or plus 2? Because if you have, remember, it's x minus h. So this is negative 2 up here, x is positive 2 down here.
Okay, so got it.
Yeah. No, it's a good point. I'm glad we talked about that. Because if it was x plus 2, then it's actually minus 2 in h part. All right, so 2, 1, and then the radius we said was 4.
4, yeah.
The intercept, so this is the hard part. Okay.
So firstly, we write the x says the x-intercepts, right?
Yes. And should we get it? Or yeah, we could do the x-intercepts first. I don't think it matters because it doesn't say specifically. It just says what the intercepts are. So we're going to do, let's see, 2 plus
the root of 15.
Yeah, so we got root. I wish there was a shortcut to it, but it is what it is. 15, and then comma 0.
Yes.
Then another comma. 2 minus root. And I wish they would just tell you whether you got it right after, but
no, it doesn't show.
I think it doesn't show you.
I did it 17 times.
Okay, I got you. And then 1 plus 2 root 3, and then we got 0 minus 2 root 3. And that's it, I think. Oh. No, I finished the book.
Yeah, because you didn't graph the circle.
Oh, graphic, yeah. Circle. And we says a 2, 1. And 1, 2, 3, 4. And we can kind of see that, yeah, this is going to be 1, and then plus or minus 2 root 12. Root 12 has got to be a little bit more than 3, but not much. And you can see 1, 2, 3, and a little bit more. 1, 2, 3, and then a little bit more. Above 1. And then for the other one, we got 2 root 15. Well, root 15 is really close to root 16, which would be 4. So you gotta think about it as 2 is gonna be plus 4. So 1, 2, 3, and almost 4. Boom. 1, 2, 3, and then almost 4. So I'm pretty confident in my answer. So that's a way you can check to make sure your answer makes sense after you've graphed it. Yay. Oh yeah, there's check extra down here. Okay.
I never saw this.
If you did this, maybe it's something you should show me.
Maybe because you're the teacher.
Maybe that's a good question. I have no idea.
I wish I had this.
Hey, me too. But you can do the review as many times as you want, right?
Yeah.
So.
And for there is a question, I can't recall it specifically, but it gives you a point, then it tells you if it's tangent to the y-axis or the x-axis.
Oh, tangent to the y-axis or tangent to the x-axis?
Yes.
Okay, let me see if I can find that one.
Yes.
This one.
So basically, if I wanna get the what I'm supposed to do is to square both of them, and the outcome of this equation is going to be the radius. So all I should do is x squared plus y squared equal 81 and 25. 81 plus 25, then it's going to be the radius, right?
Not exactly.
Okay.
Not exactly. I'm going to explain it, and I think it's going to make a little bit more sense.
All right.
So visually, let's take a look at what we're talking about. So the center's at -9, 5. So -1, -2, -3, -4, -5, -6, -7, -8, and -9. Okay, and it said -9, +5. 1, 2, 3, 4. Let's scooch up a little bit. 5. Okay, so it's right here. This point right here. Okay. That's your center. Now you can imagine this is a really, really big circle because it's what we're told is tangent to the x-axis. So tangent to the x-axis. So tangent means it touches. And specifically, it touches at one point. So basically, it should look something kind of like this. No, it's not a good circle, but you get the idea. So in other words, it will touch the x-axis because it's the x-axis. It'll touch the x-axis at only this point.
Got it.
So it's not like, so for example, tangent would be something like that. Or a tangent to the y-axis would be something like this. Now, the reason that's important is because it tells you that if it touches the x-axis, the radius has to be just this number.
Oh, the 9 squared.
Well, 5, but
if it's asking about the x-axis, if it's tangent to the x-axis,
yes.
the radius is going to be the y value or the k value.
Yes, you are correct. That's actually very true. If it's tangent to the x-axis, then you're right. Basically R equals K. If it's tangent
to the y-axis, R equal it.
R is equal to H. You're absolutely correct. Because if I said, hey, it's tangent to the y-axis, then we would be looking at, let me use a different color here. If I said, hey, it's tangent to the y-axis, we would be looking at a circle that looks somewhat like this. So this would be tangent to the y-axis. Something like that. and therefore parallel with your H. Yeah, with your H. So I say all that to say this. Okay, now you got your center point, -9, 5, and now you also have your radius, which is 5, and that should be enough information to create x plus 9 squared plus y minus 5 squared
So
equals
equal 25.
exactly. That's it.
Not a sir.
Yeah, no problem. Because it's this tangent too. It's like, what in the world does that mean? You know. But once you kind of understand it, it just means it touches at that point. Then it kind of helps.
Mhm.
All right. So let me see here. How about this one with the diameter?
First of all, we use the midpoint formula. Then
Yes.
get the answer we should get by the end of this 2 points, and we use them as P1. Then we use the distance formula, and we pick
Yes.
either point, doesn't matter. Then
Yes.
we use and the outcome of this from the distance formula is gonna be
Yes.
the radius.
You're absolutely correct about that. You're absolutely correct about that. Because HK, you just use the midpoint formula, which would be in this case 9 plus -5 over 2, and then 8 plus 2 over 2. You're absolutely right. That'd be 4 over 2, which is 2, and this would be 10 over 2, which is 5. So this would be your center, and the radius would be literally, like you said, you could pick either point, but you're finding the distance between our center and that outer point. So we know the distance equals the square root of
x2 minus x1 all squared plus y2 minus y1 all squared.
And then you got square root of x2. Let's say it's I'm gonna use -5 too, so I'll say so let's see. So I'll say something like -5 minus 2 squared plus 2 minus 5 squared.
And here we get 7 squared
plus -3 squared, which is
49 and 9,
mm-hmm.
which is basically is 58.
You're absolutely right. And so we end up with x minus 2 squared plus y minus 5 squared equals 58, because the square root of 58 squared is itself.
Yes, sir.
That's it.
That's I don't want to fail math again.
You got it.
Because if I do, I'm gonna lose my scholarship. I don't want this to happen.
I understand. I understand. I understand.
Is there any other questions that you want me to focus on?
Let's see, how many are actually on the review? I think it's 20 questions of the real thing. So yeah, I think 30 is a good span. If you feel comfortable with all of them, I think you'll be all right.
Wait a second. There is something that I don't feel comfortable with, to be honest.
All right, go ahead.
If it's odd or function, sometimes it's doesn't make sense to me. If it's odd or even, or
odd
neither.
or even, okay. Odd, even, or even. Okay, let me see if I can find one.
Yeah, you'll find one. No, these questions for you.
Oh no, yeah. I'm here to answer, try to figure out how to do it. So local max min, those are easy.
Yeah.
Intercepts, looking at the graph, good. All right. Okay, here we go. Odd, even, or neither.
This should be odd.
Yeah. It's weird. Okay, so this is what we call, this is an odd value. I agree. However, this is not going to end up being an odd function.
Okay.
And I'm going to explain why it's kind of confusing, but graphically it makes sense. So let me pull up the graph and I'll show you why it is that way. So for something, come on, up here. So if we look at, say, Desmos, which I love using. We look at negative 8x cubed. This by itself is an odd function, okay? It's odd because basically what odd means is I could take this value and turn it, you know, in other words, I could take all this right here and I could rotate it 180 degrees. I'll end up with the exact same thing. So it is odd. But let's see what happens, because I can turn it about the origin, about here. But let's see what happens when I add 9 to it. Well, is that still true? Well, no. Because if I go about the origin, it's not going to really do anything. It's gonna, I'd have to rotate about this point and not rotate about the origin. So that's why it's neither graphically.
Neither?
Yes.
All right.
So if you have something like this, that's odd. If you think about something like this, that's odd. Clear this. That's odd. If I had plus x2 fifth, this is also odd. But as soon as I have, this is also odd because the zoom out. If you zoom out, you'll see that if I was to rotate this around the origin, I'd still end up with, the same thing. Another odd function is something like this. This is also odd, because if I rotate it about the origin, I'll end up with the same thing. But as soon as I do this, as soon as I do like +5, well, now it's not odd anymore. Or if I do +10, it's not odd anymore, because I wouldn't rotate about the origin. I wouldn't rotate about 0, 0. I'll be rotating about up here.
So basically, for my understanding, if we get an odd number, like what we got in the question, x
cubed,
cubed plus a number, it should be neither, right?
That is correct.
Got
for the
it.
most part. Now, here's how you check that algebraically. So I want to show you how to check it, but I wanted you to see it visually first. All right, so here's how we check that. The way you check it is this. If something is, if something is odd, okay, that means that if I plug negative x,
it'll still negative x.
Well, yeah, that gives me the negative of the regular function. So for example, if I do, so for this case, if I do g of negative x, I end up with -8 and then negative x cubed. So suppose instead g of x was just -8x cubed, okay? It was just that. Well, then if I plug negative x cubed in, I get -8 times negative x 3 times, right?
Yes.
Well, if I multiply negative x by itself 3 times, let's see, negative times negative is positive, negative is negative, right?
Gets by then the negative number.
Right.
Or
so,
negative value.
Right. So basically it's -8 and then times negative x cubed. Well, these two negatives cancel basically, and you end up with 8x cubed.
All right.
So you can see that this is the positive version of the original. You see, the only thing that's changed, the numbers are the exact same, but the only thing that's changed is this is now positive. So therefore, this is odd. Now let's see what happens when I add 9 to it, like the problem we have. If I instead said g of x equals negative 8x cubed plus 9. Now I'm going to plug negative x in. So if I do g of negative x here, negative 8, negative x cubed plus 9, this is still going to give me 8x cubed, right?
Yes.
Good. But this is still plus 9. So notice, even though this sign has changed, this sign has not.
Yes.
So therefore it's neither. Because for it to be odd, both sides have to change. For it to be even, it has to be the exact same as the original. And for neither, it just means that either both sides didn't change or you didn't end up with the exact same result as the beginning.
Got it.
Great question.
Can you write me an example, Ted, just to make sure I got it right?
Is f of x equal to 3x to the 5th, even, odd, or neither?
This one is odd.
That is correct. Absolutely right. How can I prove it?
We basically plug negative x.
Oops. Oh, oops, wrong eraser. Got too many things going on here. All right. Yeah, we'll plug in negative x. And this gives us negative x to the 5th, which is the negative version of this. Very good.
Yes.
All right, what if you had h of x equals to 5x cubed minus x? Is this even, odd, or neither?
The x is still going to be negative, so probably it's going to be odd as well.
Yes, it is odd, right? They're both going to switch. All right, that said, what if I give you something like, keep doing that. Oh, come on. Oh, that's why it's not going. All right. What if I give you something like this? Is that going to be even, odd, or neither?
I believe it's going to be neither.
All right, so let's plug negative x and check.
All right.
So we got 5 negative x squared minus 2, which gives you negative x is negative times a negative, which is positive.
Oh, it'll stay the same.
It does stay the same, so
yeah,
therefore it is
even.
Even. Remember, the only time that adding this works is if it's
odd.
An odd, right?
Yeah.
Exactly. And the reason for that being is if you kind of look at the graph, you can see that no matter it doesn't matter how many times I add to this thing. If it's even graphically, that means it has symmetry. So like, for example, if it's even, it's like x to the 4th. X to the 4th. Even, you see there's that symmetry, right? If I add numbers to the outside, that doesn't change the fact that there's still symmetry. Does that
Got
kind
it,
of make
sir.
sense?
Yeah, way much better.
Man, you got great questions. These are really, really good questions.
Thank you so much, and thank you for.
That's what I'm here for.
And can I ask you one more question?
Sure.
Am I allowed to bring like paper with me that has all of the formulas that are included in the test, so I cannot get messed up?
Yeah, no, they don't allow to bring anything into the test except for a pencil. That's
All
pretty
right, no.
much it. I mean, really, like not even paper. Like we provide paper for you, and so what I would do is just kind of work through some of the extra resources because I really like talk about in these. So let me go back here. So, like for example, in the study guide, this is under files
Mhm.
in Canvas, and it's under files and it's under extra practice, or it says extra lessons or something like that. Basically, you'll find the study guide, and what I do is like for the formulas, I break down exactly what the formulas are, but how they're used as
Got it.
well. So what I would do is just take a quick glance at those as you're prepping, because they can be pretty helpful in terms like kind of figuring out like what to do and stuff like that. For example, like I'll write, if we have an equation x at y x symmetry, both sides y-axis mirror each other, and then x. And you see what I'm saying? So like everything I did with you just now, like I show you how to do it in examples and whatnot. So this is just another way to just kind of reinforce what's actually happening in the problem, completing the square, talk about, for example, vertical line tests, domain and range, everything we've been talking about so far. And then of course you have my previous videos as well.
Yeah.
Yeah, so
I found them helpful as well.
okay, great. So so yeah, and then the other thing is like, for example, distance and midpoint formulas are not necessarily like, even if you don't remember exactly, I like to think of it as like, so if I said, okay, what's the midpoint between 5, 2 and I don't know, 3, -4?
8 and 2, I'll basically get 4,
Yeah,
and 2 and 2, I'll basically get -1.
yeah. So in my mind, yeah. So in mine, I'm just saying like, hey, what's halfway between 5 and 3? Well, 4. Right? It was halfway between 2 and -4. Well, the way I think about it is like this. It's like you got -4 over here, you got 2 over here. If this is 0, then halfway between these two is got to be 1, right? Because it's, or -1 rather. So it's 3 on this side, 1, 2, 3. 3 on this side, 1, 2, 3. And so 4, -1. Notice I didn't even use the formula, right? And then sometimes it's kind of easy for like me, I'm a very visual person. So I like to kind of draw it out and see what's going on in the problem, right? So in this problem, I'm figuring out, okay, I've got 1, 2, 3, 4, 5, 2, which should be this point, and then 1, 2, 3, -4, which should be down here. So in other words, if I'm trying to find the midpoint between these two, it's got to be about here, which is exactly what we expected.
And I got you one more question.
Sure.
The x-axis we call a horizontal, right?
That is correct, yes.
And the y-axis we call a vertical.
That is correct, yes.
Got it. I always get messed up with this as well.
Yeah, the way I like to think about it is when you're on a beach, you're on a beach or something, and you look up, like in English, we say you look out at the horizon. That's horizontal. So if you're looking out at a beach, in English, we call this the horizon, right? So this is horizontal. And then vertical
Would be
is
this.
like the other one. But that's how I remember horizontal, horizon. is the beach.
Got it.
I like that.
All right. Thank you
All
so
right.
much, sir.
Hey, it's my pleasure.
Thank you. Have a good day. Enjoy your weekend.
Same to you. Same to you.
All right.